old link is
Then
expired.
how they will come now?
Yeah, now they will come. I'm just informing. Everyone got a
Okay.
new mail.
Okay, ma.
Whoever
Inform.
registered yesterday.
Okay, okay. Inform them. Inform them.
Okay, ma'am. Okay.
Okay, we'll start then. Okay.
Okay, ma'am. Thank you. Okay, ma'am. Okay. Thank you.
Are you able to see PPT now? Students?
Yes, ma'am.
Okay, ma. Just I will revise
Yes,
this
ma'am. Yes, ma'am.
treatment methods, ma. Then we'll complete today chlorination and ozonization. Then I want to complete reverse osmosis also. So with reverse osmosis, we are going to complete water technology, ma. Second module. So we know what is potable water. That is water free from contaminants. Okay, water that is safe for human consumption is called potable water. Okay, so what are the specifications? Means the water should be clear, colorless, odorless. The turbidity should not exceed 10 ppm. The hardness of water must be 125 ppm and pH must be 7.0 to 8.5. The water should be free from heavy metals like lead, arsenic, chromium, manganese, and also dissolved gases such as H2S and CO2. And water should be free from pathogenic microorganisms. Okay, these are the specifications of potable water. Now, there are some steps involved in treatment of potable water. So first step is screening. So where we can remove large floating matters like leaves or bark of wood. Okay, so that by using a large mesh screens, so we can remove the large floating matters present in the water. Sedimentation, we are taking a big tank and we are passing the water into the big tank, and we will undisturbed for 2 to 5 hours so that all the suspended particles will settle down at the bottom of the tank, and clear water we are collecting with the help of the pumps. Now third step is coagulation. To remove very fine particles present in water, colloidal particles, so we are going to use coagulants. Example is what we are using chemicals are aluminum sulfate and sodium aluminate. So when we are adding this aluminum sulfate or sodium aluminate, so what we are getting in the water is aluminum hydroxide flux. Okay, so this aluminum hydroxide flux, so this will attract the impurities. This will attract the negatively charged particles present in the water, and it will form like a bigger flux. Okay, it will form like a bigger flux, and by gravitational force, so that will settle down at the bottom of the tank. And here, after that, we go for filtration and we'll collect the clear water. So that is the third step. Okay, coagulation. And fourth step is filtration. So here we are going to remove infiltration colloidal matter, if any colloidal matter present, and bacteria, microorganisms are removed. So we are using sand bed here. We are using sand bed, okay, large area sand bed. We are passing the water through the sand bed and we are filtering the water, so that by using sand bed, we can remove bacteria, colloidal matter, microorganisms, but completely we cannot remove bacteria, so that we are going for the the step, fifth step is disinfection. Okay, this is the important step what we are going to discuss, disinfection. What is mean by disinfection? Means that is it is the process of destroying or killing the bacteria present in water. It is the process of destroying or killing the disease producing bacteria present in water. Okay, so that is known as disinfection. What is disinfectants means? So the chemicals which we are using to kill the bacteria, okay, the chemicals which we are using to kill the bacteria, that are called disinfectants. Okay, so what we are using the chemicals here means, in potable water we are using chlorine. We are using chlorine and ozone. Okay, so first method, that is, we know general method, boiling. We are boiling the water at our homes. We can boil the water 10 to 15 minutes so that we can destroy the bacteria, or we can kill the pathogenic bacteria present in water. Okay, so second one, that is chlorination. We are going to use here in chlorination bleaching powder, okay, or chloramines, or we can add directly chlorine in water, okay. So here in chlorination, so what is chlorination? What is chlorination means? The process of utilizing chlorine as a powerful disinfectant. So now chlorine is a disinfectant, okay. Why? By using chlorine, so we can kill the bacteria. So it is called disinfectant. So the process, what is chlorination means? The process of utilizing chlorine as a powerful disinfectant is called chlorination. So first one, we are using bleaching powder. Okay, bleaching powder, that is known as calcium oxychloride. Calcium oxychloride. We are adding in water. So what we are getting when we are adding in water, we are getting calcium hydroxide and chlorine. Calcium hydroxide and chlorine. So this chlorine in presence of water, so we are getting hypochlorous acid. Hypochlorous acid. So this hypochlorous acid, it will kill the germs or bacteria present in water. Okay, ma? But here one disadvantage by using bleaching powder is it introduces, okay, hardness in water. It introduces hardness in water. So that is disadvantage when we are using bleaching powder as a disinfectant. Okay. So, and also excess of it gives bad smell and bad taste. We cannot use more bleaching powder. We'll get a bad smell and bad taste. And also we get here excess of chlorine. It is irritating to mucous membrane. So that is the, we are using bleaching powder. Next, we are using chloramines. So chloramines are prepared here by using chlorine and ammonia, okay, in 2:1 ratio. And when we are taking chloramine in water, we are getting hypochlorous acid. So this hypochlorous acid, it will kill the bacteria. So mainly we use this chloramines. It is useful for disinfecting in swimming pools. So next we are adding directly chlorine to water. Directly we are adding chlorine to water. Okay, but here what we are going to discuss today is how much quantity of chlorine we have to add to destroy completely bacteria present in water. Okay, because if we add excess of chlorine, it leads to the, means we are getting bad taste, bad odor, and also it is toxic to human beings. So we have to add exact quantity of chlorine in water. Okay, so we go for like it is like experimental method only. So we will discuss with graph. So calculated amount of chlorine must be added. Calculated amount of chlorine must be added to water because chlorine after reacts with bacteria present in water and also the impurities present in water, organic impurities present in water, and also chlorine reacts with ammonia present in water. Okay, after reacting with the impurities present in water and ammonia present in water and also bacteria, destroying bacteria, and now if any chlorine is remaining in water, that is known as residual chlorine. That is known as residual chlorine, which gives bad taste, bad odor, and it is toxic to human beings. So how we can know exact amount of chlorine, how much we have to add in water is by breakpoint chlorination. By breakpoint chlorination. So the amount of chlorine required to kill bacteria and to remove organic matter is called breakpoint chlorination. So the water sample is treated with chlorine and estimated for the residual chlorine in water. Okay, and plotted a graph. Okay, we will plot a graph. With that, we will know how much chlorine we have to add in water. Okay, so which gives breakpoint chlorination. Now you can see the graph here, ma. Okay, you can see the graph. 0, 2, 6, 10, 14. For example, we are adding chlorine dose milligram per liter. Okay. For example, we are taking first 1 milligram, 2 milligram, 3 milligram, 4, 5, 6. Okay. So when we are adding initially, for example, 8 grams of chlorine I wrote here. Okay. But I am telling now 1 gram of chlorine. So 1 gram of chlorine when we are adding in water, 1 gram of chlorine when we are adding in water. Okay, ma? So what happens here? Okay, it oxidizes, reducing impurities present in water. It oxidizes, reducing impurities present in water. What are the reducing impurities? For example, iron, manganese, nitrate. So initially when we are adding chlorine, for example, we are adding 1 gram of chlorine in 1 liter. Okay. So when we are adding 1 gram of chlorine, what happens here? It oxidizes all reducing impurities present in water. For example, iron, manganese. Now next 2 grams of chlorine we are adding. 2 grams of chlorine. Next to 2 grams of chlorine we are adding. When we are adding 2 grams of chlorine in water, okay, it forms chloroamines. It forms chloramines, okay, and other chloro compounds. Means the chlorine, it reacts with the ammonia present in water. The chlorine reacts with the ammonia present in water. Look at the graph, okay, ma? The chlorine reacts with the ammonia present in water, okay, and forms chloramines. And forms a chloramines and other chloro compounds. Okay. Next, ma, when we are adding, for example, 3 grams of chlorine. Okay. So when we are adding 3 grams of chlorine, it causes destruction of bacteria. It causes destruction of bacteria. Okay. And when we are adding 4 grams of chlorine, okay, 4 grams of chlorine, that is known as residual chlorine. That is known as residual chlorine. Okay. Now here, we can see the graph now. Everybody look at the graph now. You can understand very clearly. Everybody see here. So initially when we are adding 0 to 2 grams, 2 milligrams, okay. So it is oxidizes all reducing impurities present in water. After 2 grams, you can see the curve slowly increasing. It reaches to maximum. Okay, why? Because here what is formed in the water? Chloramines. What is formed in the water? Chloramines. Clear, ma? Chloramines are formed in the water. Okay. So after forming chloramines, then you can see the graph is decreasing here. It reaches to minima. Okay. The graph is decreasing here. Why? Means when we are adding, for example, 6 milligram chlorine to 10 milligrams when we are adding, here the chloramine, okay, chloramine in presence of water. So what we get? Hypochlorous acid. Hypochlorous acid. That hypochlorous acid, it is destroying the bacteria present in water. It is destroying the bacteria present in water. Okay, slowly, so that the curve is slowly decreasing here. So at point C, all the bacteria killed here, all the bacteria destroyed at point C. At point C. After point C means at 10 milligram chlorine when we are adding, up to 10 milligram chlorine when we are adding. So that is sufficient for us now. Okay, because up to 10 milligram liter of 10 milligrams of chlorine, using the 10 milligrams, so we can kill all bacteria present in water. So point C is known as breakpoint chlorination. Point C is known as breakpoint chlorination. So after that, when we are using chlorine, then means we are adding 11 milligrams, 12 milligrams, 13 milligrams when we are adding chlorine. So again, you can see here, the curve is increasing. The curve is increasing means excess chlorine is there in water. Excess chlorine is there in water. We know no need that chlorine for us now, because all the bacteria killed here. We destroyed all the bacteria. Okay. So that is called d grams of chlorine, ma. D grams of chlorine is nothing but residual chlorine. It is excess chlorine in water. Okay. No need for us excess chlorine. Okay. So because if excess chlorine is there in water, then we get a bad taste, bad odor, and also it is toxic to human beings. Okay. So this is about breakpoint chlorination. Okay. So I think everybody understood my curve. So initially you can see, you can see here, in this graph, you can see initially there is no you won't observe in curve. Okay, there is no increase in curve also here initially, because whatever fluorine you are adding, like 1 gram, 2 gram, 3 gram, okay, for example, it is oxidizing all impurities present in water. It is oxidizing all reducing impurities present in water. Then after that, you can see the curve is increasing because the chlorine, it is reacting with ammonia present in water. Means when you are adding like up to 3 grams of chlorine, when you are adding, it is oxidized, it oxidized all reducing impurities present in water. After that, when you are adding 4 gram, 5 gram, 6 gram, you observed that the curve is increasing. Why? Means the chlorine is reacting with the ammonia present in water. The chlorine is reacting with the ammonia present in water and forming chloroamines. Chloramine is a powerful disinfectant. Chloramine is a powerful disinfectant. So in presence of water, what happens? We get the hypochlorous acid. Hypochlorous acid. You can see here. We get the hypochlorous acid. So this hypochlorous acid, okay, it inactivates the enzymes. Okay, it inactivates the enzymes of bacteria and it will kill the bacteria present in water. Okay, so here C grams of chlorine, that is breakpoint chlorination. After forming chloramines, then we get hypochlorous acid. That hypochlorous acid will destroy the bacteria. When it is destroying bacteria, then the curve is decreasing. When it is destroying bacteria only, the curve is decreasing. It reaches to minimum. It reaches to minimum. When chlorine is there in water, you can see it is known as combined chlorine. Chloramine, when it is formed in water, it is known as combined chlorine. Then the curve reaches to maxima. Curve reaches to maxima because the chlorine is there in water. Okay, chloramine is formed in water. Why it is reaching to minima? Here in this, why it is reaching to minimum is here the hypochlorous acid is destroying bacteria. So that you can see in the graph, so the curve is decreasing. Okay, again curve is increasing. Why? Because here already at point C only, all bacteria destroyed here. Then also we are adding excess chlorine. Excess chlorine is there. D grams of chlorine is nothing but excess chlorine. No need for us that chlorine. Okay, so that is known as residual chlorine. That is known as residual chlorine. So when we are adding A grams of chlorine, it oxidizes, reducing impurities of water. When we are adding B grams of chlorine, for example, 2 grams of chlorine, it forms chloroamines. It forms chloramines and other chloro compounds. So chlorine is there here, chloramines. So curve will be increasing. It reaches to maximum. So in C grams of chlorine, okay, hypochlorous acid is formed. Means it is destroying bacteria completely. It is destroying bacteria at C grams of chlorine. Means for example, 3 grams you are adding here. For example, at C grams of chlorine added causes destruction of bacteria. Now completed here. Okay, at C gram is sufficient for us. Okay, so 3 grams is sufficient for us to kill the bacteria. Now when we are adding D grams of chlorine, for example 4 grams of chlorine, okay, so this is known as like a residual chlorine, that is excess chlorine present in water. Excess chlorine present in water. Okay, ma? So this no need for us because we get a bad taste, bad odor, and also it is toxic to human beings. Means if we get bad taste, we can't drink the water. Yes or no? If we get bad taste, we can't drink the water. If we get bad odor, bad smell, we can't drink that water. Okay, so when we are going for chlorination process, we have to add exact amount of chlorine to destroy the bacteria present in water. So remember students this one. Okay, so how we can know that exact amount of chlorine? Means with the help of the graph. Means we will do experiment with the help of the graph. We can know how much amount of chlorine, exact amount of chlorine we can add in water. So C grams is the break point. C grams is the break point for addition of chlorine to water. For addition of chlorine to water, this is called break point chlorination. This is known as break point chlorination. So what are the advantages? Very good advantage is there. by following this breakpoint chlorination. Okay. So by knowing the exact amount of chlorine, how much we have to add, so that it removes bad taste and color. Okay. And it oxidizes completely organic compounds, impurities present in water. Okay. Ammonia, it reacts with ammonia present in water and other reducing impurities also. Okay. So we won't get any bad taste, bad odor. We can remove the reducing impurities present in water. So by following the, okay, breakpoint chlorination. And also it destroys completely all disease producing bacteria. It destroys completely all disease producing bacteria, because if you are adding less amount of chlorine, we cannot destroy the bacteria completely. We cannot destroy the bacteria completely if you are adding less amount of chlorine. If you are adding excess amount of chlorine, you get bad taste, bad odor. Clear? So that we have to know that we have to add exact amount of chlorine to water to destroy all the bacteria present in water. Understood my breakpoint chlorination? Students, so you have to add slowly 1 gram, 2 gram, 3 grams of chlorine in water, so that we can understand, okay, at which point we can kill all bacteria present in water. So next one is the disinfection by ozone. Okay, so but this is costly process, like expensive method. Municipality people, they won't follow this. Okay, municipality people, they won't follow this. Okay, in Hyderabad also, municipality people, they won't follow this method. Disinfection by ozone, this is expensive. Okay, so now we are taking ozone. It is excellent, harmless disinfectant. Okay, so it is highly unstable. Ozone is highly unstable, so it will be easily decomposes to give nascent oxygen. So here nascent oxygen is the powerful disinfectant. Nascent oxygen is the powerful disinfectant. So it oxidizes organic matter present in water and also kills the bacteria. Organic matter present in water and also it kills the bacteria. So we will pass the ozone in water. Okay. So what we get, since ozone is highly unstable, so it will be immediately, it will be decomposing into oxygen, and it will be decomposing into oxygen and nascent oxygen. So this nascent oxygen only, this is a powerful disinfectant, oxidizing agent, so that it will oxidizes all organic matter present in water, and also it will kill the bacteria present in water. So only I gave this only, I am not giving more about ozonization. Okay, about chlorination only we are discussing in potable water. So only this you write, okay, no, for ozonization. Now students, hello. Hello students.
Yes, ma'am.
Now tell me how to find out how much exact amount of chlorine how to add in water to destroy the bacteria. How to know? Hello?
By adding, like, first we'll add 8 grams of chlorine. So that will oxidize all the reducing impurities. And the second thing, when we add B grams of chlorine, it will the chlorine forms chloramines and other chloro compounds. And when we go on adding another C grams of chlorine, it will cause destruction of bacteria.
What forms it?
Ma'am?
At C grams of chlorine, what is forming?
HOCl.
HOCl.
So that will that's a powerful disinfectant, and it will destroy bacteria. And at D grams, it's called residual. C grams is called a breakpoint of chlorine.
So D grams of chlorine is for us, it is needed. It is needed for us.
No, ma'am.
D grams of chlorine is called
residual chlorine.
Residual chlorine. So if you are adding excess chlorine, what happens?
bad taste, odor, and toxic. It will
Yeah,
increase
it
the
is.
toxic of.
We get all the health problems. Okay, toxic to human beings. If you are adding less amount of chlorine, then what happens? Less amount of chlorine. Less amount of chlorine if we add in water.
It does not kill the bacteria
It does
completely.
not kill the bacteria. We cannot use as a drinking water. Yes or no? Yes, ma? So now tell me how many steps are there in potable water?
5.
Now what are that?
Screening,
Sedimentation,
Mm.
coagulation, filtration,
disinfection.
disinfection.
Disinfection. Okay. So in disinfection, what we discussed, ma? 3 points are there. What is the first point? At home, what we do?
Bleaching,
Boiling. We will boil the water to kill the bacteria present in water. Okay. So chlorination, how many steps are there?
3.
3. First, which chemical we are using?
Bleaching powder,
Bleaching powder. Second chemical?
Chloramine.
Chloramines. Third chemical?
Chlorine.
Directly chlorine we are adding. Directly chlorine we are adding in water. Okay, that is chlorination. What is the other step? What is the other method? 2 methods are there. One is chlorination. Next one is
Ozone.
ozone. Directly we are passing ozone into water and we can kill the bacteria present in water. But this is expensive method, ma. So municipality people, they won't follow this method. Okay. Students, one question for you. What is coagulation? Very simple. Coagulation. What are the chemicals we are using for coagulation process?
Aluminium sulfide.
Aluminium sulfate.
Sulfate and sodium aluminum oxide.
Sodium aluminate. Sodium
aluminate.
Aluminate. Okay. When we are adding these chemicals in water, what happens?
Forms flock.
It forms flocks. It forms flocks. So this flocks will remove. These flocks will remove what it will
Colloidal
remove?
particles in the
Colloidal
water.
particles present in water. Okay, ma? Okay. So students understood, ma, this treatment of potable water? Hello?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
We'll go to the other topic.
Yes, ma'am.
I will ask one last question. Why here curve is increasing? Tell me. Initially, you won't observe anything. Okay. Okay. But here the curve is increasing. For example, for 2 grams of chlorine to 3 grams of chlorine, you can see curve is increasing. Why? This is important.
Forms chloramines and other chlorine compounds.
And other chloro compounds in water. Okay. So why curve is decreasing here? It reaches to minima. Why?
It killed all the bacteria.
Kills all the bacteria present in water. Okay, it kills all the bacteria present in water. Why curve is increasing here?
Because of residual chlorine.
Because of the residual chlorine in water. Okay. Now, students, this is the last topic in module 2. Okay. So what we discussed till now is, this is very short topic. Okay. Simple topic. So we discussed now, till now, hardness of water, types of hardness, temporary hardness, permanent hardness, units of hardness, expression of hardness. That is, we know the formula of hardness and we calculate, we have done the problems also. Then EDTA method. Then after that problems, ma. Okay. So next ion exchange process, that is external treatment of water. So then potable water. Okay, this is the last topic. So last topic is the desalination. Students, see the PPT, everybody. On your video. On your video, everybody. So desalination, okay, ma, we will discuss in this only one topic here, reverse osmosis. I think you know already about osmosis. Okay, we will discuss that. So water containing high concentration of dissolved solids, ma, with a peculiar salty or brackish taste is called brackish water. Means if the water is containing sodium chloride, more percentage of sodium chloride, that is known as brackish water. Students, if the water is containing sodium chloride, more percentage of sodium chloride, so that is known as brackish water. Okay, so seawater is an example of brackish water. Seawater is an example of brackish water. It contains 3.5% of dissolved salts. 3.5% of dissolved salts. So what is present in seawater means sodium chloride. So it is known as brackish water. So before the removal of these salts, okay, if we are not removing sodium chloride or any other dissolved salts present in water, we cannot use that water for either domestic purpose or industrial purpose. So we have to remove the sodium chloride present in water. So what is the process is? That process is known as desalination. Salination means nothing but sodium chloride present in water. Salination means sodium chloride present in water. Desalination means removal of sodium chloride. Removal of sodium chloride. So that is present in water. So the process of removal of sodium chloride present in water is known as desalination. The process of removal of dissolved salts. Okay, I wrote here sodium chloride because more percentage of sodium chloride will be there in seawater. So the process of removal of sodium chloride present in water is known as desalination. So students, what is desalination means? What you will write? What is desalination?
The process of removal of dissolved salts present in water is known as desalination.
So the process of removal of sodium chloride present in water is known as desalination. Now you see here, seawater, it contains the salinity, it will be greater than 35,000 milligram per liter. 35,000 milligram per liter. Okay. Brackish water will be, the salinity will be milligram per liter. 1,000 to 35,000 milligram per liter. Salinity, if it is there in water, it is known as brackish water. It is known as brackish water. Fresh water means the salinity of water, it is less than 1,000 milligram per liter. Less than 1,000 milligram per liter. Okay. So brackish water and seawater are not fit for drinking. Okay. And also for industrial purpose, we cannot use. So we are going for the process desalination, that is removal of sodium chloride present in water. So first we have to know what is the osmosis. What is osmosis, students? You know already. What is osmosis? Very simple. When we are taking here, for example, you see this diagram. Okay, you see here. I have taken in I have taken one chamber or one beaker. I have taken and I have taken semi-permeable membrane in the middle, and in one side I have taken a concentrated solution, the other side dilute solution. So what is mean by osmosis? Somebody already in chat box, they have given that it is low concentration to high concentration. Means what? Low concentration to high concentration means, see, one side we are taking, okay, both we are taking 100 ml water, ma. So in one first chamber we are taking 1 gram of sodium chloride. Second chamber I am taking 5 grams of sodium chloride. Which is known as concentrated solution now? Students. See, in this first chamber, I have taken dilute solution. That is 1 gram of sodium chloride I have taken in 100 ml. In second chamber, I have taken 5 grams of sodium chloride in 100 ml.
Chamber is more concentrated.
First chamber is more concentrated solution or second chamber?
Second chamber.
First chamber, I am taking 1 gram of sodium chloride in 100 ml. Second chamber, I am taking 5 grams of sodium chloride in 100 ml. Which is more concentrated solution? Second chamber. First chamber? First chamber? Dilute solution. First chamber, dilute solution. Second chamber is?
Concentrated.
Second chamber is dilute, ma? Somebody typed second chamber dilute. Which is diluted solution, ma?
First chamber.
Where will be more solute particles? Tell me. First chamber or second chamber?
Second
See,
chamber.
sodium chloride I have taken in water, ma. Sodium chloride. I have taken 1 gram of sodium chloride in water. Which is solute? Which is solvent? Tell me. Which is solute? Which is solvent?
Solvent is like water and solute is like sodium chloride.
Solvent is water, solute is sodium chloride. Yes or no? Okay. So second chamber, I have taken 5 grams of sodium chloride in 100 ml water. First chamber, 1 gram of sodium chloride in 100 ml water. So in these two chambers, where will be more solute particles? In which chamber?
Second chamber.
Second chamber. Second chamber will be more solute particles. It is concentrated solution. Yes or no? Yes, ma'am.
Yes,
So
ma'am.
what is osmosis now? So osmosis is the flow of solvent. What is solvent here? You know what is
Water.
solute? What is
Water.
solvent? Solvent is water. Solute is?
NaCl.
Solute is NaCl. Solute is NaCl. Solvent is water. So
Water.
what is the process of osmosis means? So it is the process by which flow of solvent takes place. Flow of solvent takes place from a region of lower concentration to higher concentration. Lower concentration to higher concentration. Okay. So not high concentration to lower concentration. Okay, na? So the flow of solvent, the flow of water molecules from lower concentration to higher concentration. When two solutions of different concentration, these are separated by a semi-permeable membrane. Semi-permeable membrane. So this semi-permeable membrane, it allows only solvent. It allows only solvent molecules, not solute molecules. It will allow only solvent, not a solute. Okay. So the osmosis process, the flow of solvent takes place from low concentrated to high concentrated solution. You can look at here in the diagram. Okay, this is dilute solution. This is concentrated solution. Now you can see the movement of water molecules from lower concentration to higher concentration through the semi-permeable membrane. So the flow continues here. Okay, the flow continues. Okay, till the concentration is equal in both the sides. Okay, so this how this force is taking place here. The driving force for osmosis is osmotic pressure. Okay. The same thing I gave here also. Okay. It will allow only solvent but not solute. So you can see in this diagram also, okay, the flow of the movement of water molecule from lower concentration to higher concentration. Now, so what we are discussing is now reverse osmosis. Okay, osmosis means the flow of solvent. It takes place from lower concentration to higher concentrated solution. But we are following the process in a reverse way, opposite. Okay, means the flow of solvent, it takes place from higher concentrated solution to lower concentrated solution. Okay, how does it takes place? How it happens? we are applying extra pressure on the higher concentrated side solution. We are applying the pressure so that the flow of solvent, it takes place from it, the flow of water molecules, it goes from higher concentrated solution to lower concentrated solution. Okay, so this we have to discuss with the diagram. Okay, so one diagram is there. So this diagram you have to draw in the exam. Okay, so where we are taking you can see here two chambers are there. So in first chamber we will take sea water. Okay, second chamber pure water, and this is separated with the semi-permeable membrane. So this semi-permeable membrane, it is made up of means we use the polymers, polyamides, okay, polymethacrylate polymers we use as a semi-permeable membrane. So then we apply the pressure on the concentrated side solution, okay, sea water, so that the flow of solvent, it takes place from higher concentration to lower concentration. Means only water molecule, it is the semi-permeable membrane, it is allowing only the water molecules, not a solute. Means the sodium chloride, it remains in upper chamber only. Okay, not the semi-permeable membrane, it is not allowing the solute particles, it will allow only solvent particles, means solvent molecules, and water, it flows through semi-permeable membrane and we can collect that water. Okay, that is known as RO water. Okay, so students, this I have to discuss. Okay, this method will continue in the next class. Okay, because applications are there, advantages are there. Shall I stop the class? Students,
Madam.
shall I stop the class?
Yes, ma'am.
So we'll continue in next class, reverse osmosis. Okay, na?
Okay, ma'am.
Okay.